16b, sine and cosine. We are going to draw our unit circle again. Right, so if we draw a line from the origin out to here, and we say, well, if we want to know what that point x and y is, what's the coordinates? What are the values of x? What are the values of y? What we can do is we'll make a little triangle. A little right-angled triangle. This will be our theta in here, our angle. And this here will be x, right? Because this x here and this x here match up. And across here will be our y value. Right, so what you actually find is that if you're looking for the x value of the point around the circle, it's going to be the same as the distance of the base of that triangle, because it's going from 0 to that number. So we can actually find what that length is, and it's going to be the same value at our point. If we find the length of the base of that triangle, that is going to be the same value as that x point. There. Because you're going from 0 to that number. So if it was like a length of 5, this x value at that point would be 5, right? So thinking back to your trig ratios, does anyone know how you would find the length of the base of the triangle? Trig ratios, not Pythagoras. What's the length of this hypotenuse? It's 1, yeah, because the radius of the circle is 1. Right, so the hypotenuse is 1. Right, if you want to find the base, that's adjacent to the angle. So you got adjacent and hypotenuse. What do you use? Yeah, cosine. So cosine angle equals adjacent over hypotenuse, which in this case equals x over 1. So we can say that cosine of our angle is equal to x.
It'll just be the value of cosine.
If you take cosine of the angle that you're given, you'll find the x point of the coordinate, x value, yeah. Okay, what about if we want to find the y value? So that would be the the vertical distance of the triangle, the height. Yeah, use sine, because that's the opposite side. Sine angle equals O over H, opposite over hypotenuse. So therefore, we've got our y over 1 so sine theta equals y. Right, so super important that you remember those two things. Sine theta equals y and cosine theta equals x. Yep.
Will we be given the value of n?
Yes, you will. I just want to keep my unit circle, so I'm just going to rub that out. Okay, we want to know cosine pi. What was cosine theta? Was it x or was it y? X. So basically what this is saying is what is the x value of the point at pi? Now, when we looked at last lesson, where is pi around our unit circle? Yeah, good. So you start here. We go around the circle this way to here, which is pi. So basically, it's just saying what is the x value at that angle pi? Yes. So what would sine pi be? Sine is what? X or y? Y. So what's our y value at pi? It's 0. Okay, what about sine 3 pi? Where's 3 pi? Start here. You go all the way around this way towards pi. You keep going around all the way to 2 pi. Keep going back around, and you're here again. So this is actually equivalent to sine 2 pi plus pi. 2 pi plus pi is 3 pi. We know that sine 2 pi, well, that just takes you back around to the start, so it's equivalent to 0. So you're just left with sine pi, which we already figured out was 0. It's the y value at pi. Okay, cosine 5 pi on 2. Well, let's have a look. So we start here. Right, it's measured in halves, so we just got 5 halves basically. So we go 1 half, 2 halves, 3 halves, 4 halves, 5 halves. So we're here. Okay, so this is saying the same as cosine 2 pi plus pi on 2. Because 5 on 2 is 2.5. Which we say is equivalent to just that bit. Because the 2 pi just cycles back to the start. And then cosine is just our x value at pi on 2, which is 0. Okay, I'll squeeze it in here. This one here, it equals 0 because cosine is the x value at a certain point. The point is this one here, pi on 2, which we said was this point here. Right, so what's the x value at that point? 0. Is it always 0? At that point it is, yeah. Because it's on the y-axis.
So for pi over 2, always 0?
Yes. For cosine, but if you said sine, then if you're looking for sine, then it's the y value, which is up here is 1.
Okay. So we see on my computer. So that means that was like in this we don't use tan.
We're doing tan tomorrow.
Okay. But the sine and cosine thing depends on which way the triangle is drawn and what angle we have.
No, the sine and cosine just determine if you're looking for the x or the y value
But doesn't
at that point.
Depend where the angle is? Like if the angle is up the top.
Yeah, they're going to change depending on what angle it is and if it's sine or cosine. Okay, so sine 15 pi on 2. Now, what's 15 divided by 2? 7.5. So that's 2, 4, 6. Is that 3? 7.5 pi. 7. That'd be 6 pi. Yeah, be 6 pi plus another 1.5 pies.
Why can't you just do 7.5?
You can look at it either way. I just do multiples of 2 pi because then it like cycles back to the start. But if you want to just count you can just split them into halves and just count up to 15 if you want. Yeah.
Can you just do wholes and then
Yeah.
And a half?
Yeah, you can do that.
Okay.
But will it get harder when
Yeah, it means the same thing if you did sine 7 pi plus pi on 2. Means the same thing. You can look at it however you like. So, go blue. Right, so start here. Just count 7.5 pies. So we go 1, 2, 3, 4, 5, 6, 7.5.
Yes.
So you say, what is the y value? Yeah. Yeah. So what's the y value at that point? It's -1. So the only reason that I do it this way is because then you can just say, because 6 is a multiple of 2, you can just say that it's equal to sine 3 pi on 2, which you can work out straight away because 3 pi on 2 is here. But if you want to count, you can. It's just when you get to very large values, say if it said 218 pi on 2, then you're not really going to count 218 times around. Okay, that's it.